Those who are online, did you complete the test?
Doing.
Upload it fast. Here it is over. I'm not doing. So I'm starting. Okay. So now we'll get started with the next topic, that is parallelogram law of vectors. If there are two co-initial vectors which are represented along the two sides, basically along the two adjacent sides of a parallelogram, then the resultant is given by the common diagonal, which is starting from the common point of both vectors. Is that clear? Okay. So let us see the diagrammatic representation of it. You're copying it? Okay. So if there is a vector A like this, which I call it as A vector, if there is another vector B, which is like this, if both the vectors are starting from the same point, they are called as co-initial vectors. Okay. Now, if you see, I can say A vector and B vector are adjacent sides of a parallelogram, right? Then the resultant of these two is given by the common diagonal that is passing through the starting point of these two vectors. Then how is it possible? For that, I need to complete a parallelogram, which I will do by drawing a vector parallel to A, which is also A vector, meaning this A vector and this A vector are the same, or I can call them as equal vectors. Similarly, I will construct an other vector which is parallel to B, which I'll call it as B vector. so that we are able to complete a parallelogram. So basically, how many vectors are there? We have only two, but with the help of those two vectors, we are able to construct and form the remaining two sides by using the concept of equal vectors, so that you are able to complete a parallelogram, and the common diagonal that is drawn from the starting point of these two vectors will give you the resultant, which is R vector. So mathematically, what we can say is R vector is equal to A vector plus B vector. This is the mathematical expression. Now we'll do one thing. We will try to derive the magnitude of R vector. Means what is going to be the length of R vector in terms of magnitudes of A vector and B vector. For that, let us consider the angle between these two vectors as theta. Now, if I extend the side AB, so that from point C I am able to drop a perpendicular, then I can say if this angle is theta, then this angle will also be theta because they are corresponding angles. And I have dropped a perpendicular, and let me call that point as E. Now, if I take a separate diagram for BEC, which is a right angle triangle having an angle theta at point B and 90 degrees at point E, and BC being equal to B, because magnitude of B vector is B. Now what I can do is, I will use trigonometry by writing CE divided by, correction, CE divided by B is equal to sine theta, because it is opposite divided by hypotenuse, which implies CE is equal to B times sine theta, and let me call this as equation number 1. In a similar way, I can write BE divided by B is equal to cos theta, which implies BE is equal to B cos theta. Let me call this as equation number 2. So to put it in simple terms, this will be B cos theta, and this side will be B sin theta. So make a note till this point. How many of you that started this chapter in school? They're done also. Projected motion is also done. For you, motion is straight line. Didn't start. Last part. But then you should know all these things. Shall I proceed? Yeah. Now concentrate. If I redraw the parallelogram here, then this is AB, C, D, and this angle is theta. Here also it is theta. You have this as B sine theta and this as B cos theta. And you have the diagonal whose length is R. So from this parallelogram, I'm only concerned about a right angle triangle. So for that, what I will do is I will consider the right angle triangle CEA so that AE is going to be equal to A plus B cos theta. Similarly, CE is going to be B sin theta and AC is already R. So if I look at the right angle triangle, I can start using the Pythagoras theorem, which says R square is equal to A plus B cos theta the whole square plus B sin theta the whole square, which implies R square is equal to A square plus B square cos square theta plus 2AB cos theta plus you have B square sin square theta. Now R square will be equal to, I'll combine these two expressions, correction, I'll combine these two terms, that is B square cos square theta and B square sin square theta, so that it becomes A square plus B square into cos square theta plus sin square theta plus 2 times AB cos theta. So R square is going to be equal to A square plus B square plus 2 times AB cos theta, because cos square theta plus sin square theta gives you a 1. That's what the trigonometric identity tells us. So if you observe, if R square is A square plus B square plus 2AB cos theta, then R is going to be equal to root of A square plus B square plus 2 times AB cos theta. And this is going to be the magnitude of resultant vector. Please make a note of this. Is this point clear to everyone, including people who are online?
Yes, sir.
it clear? Shall I proceed? So this expression is a very, very, very important term in not only in this chapter, it is throughout physics. Because wherever you have vectors, and for those vectors, if they have a relation that they are aligned in particular direction, and you want to find the resultant of those two vectors, the only option that we have in our hand is using parallelogram of vectors. Okay. And the next point related to the parallelogram law of vectors is, you remember we drew this right angle triangle CEA, and AC gave you the resultant, where CE was B sin theta and AE was A plus B cos theta. If you see, the resultant is actually making an angle. Let's call that angle as alpha. The resultant is making an angle with the AB vector, that is A vector. Is it clear? Or AE vector also I can say it. Right? When that is the scenario, can I say tan alpha is equal to B sin theta divided by A plus B cos theta? Because tan is opposite divided by adjacent. So tan alpha is equal to B sin theta by A plus B cos theta, or alpha will be equal to tan inverse of B sin theta divided by A plus B cos theta. And if you see this angle alpha, it is the angle made by the resultant with A vector. Okay. And angle in physics means direction. So sometimes what they will ask you is, what is the direction of resultant? So when they use the word direction of resultant, indirectly they're asking you, what is the angle made by the resultant with either of the vectors? In this scenario that we have considered, it is angle made by the resultant with the A vector. Okay. Make a note of this. Am I clear with this? Shall I proceed? Yes? Okay. Listen to this. So here, an important point that we need to make a note of is relation between triangle law and parallelogram law of addition of vectors. If you observe in triangle law, you have two continuous vectors. That is, the head of the first vector will coincide with the tail of the second vector. Then the resultant is given by the closing side of the triangle taken in the reverse order, for which you will write R vector is equal to A vector plus B vector. So this is with respect to triangle law. Whereas with respect to parallelogram law, you have two co-initial vectors. So if this is A vector and this is B vector, then the resultant is given by the diagonal that is passing through the common tail of these two vectors. But what did we do in the construction part? We took a side A like this and we took a side B like this. Now, this ABCD forms a parallelogram, but if you observe only AB vector and BC vector, which is taken from this parallelogram, then AC vector is given in this format. R vector is equal to A vector plus B vector. Means the parallelogram law says that the parallelogram can, I repeat, the parallelogram law says that the parallelogram can be broken into two triangles in such a way that the co-initial vector, by you constructing a parallel vector or equal vector, what you can do is you can still connect it to the triangle of addition of vectors. So to conclude the whole story, what I'm trying to tell you here is triangle of addition of vectors and parallelogram law of addition of vectors are the same. Okay. So means if you're calculating the resultant R vector as A vector plus B vector, then magnitude of R vector is given as root of A square plus B square plus 2AB cos theta, irrespective of whether it is going to be parallelogram law of vectors or triangle law of vectors. The only thing is parallelogram law of vectors helped us derive this expression with ease. So, but this point has to get registered in your mind that they both are the same laws. Is that clear? Okay, make a note of this. Let me know once you're done. So now we have discussed a very important topic, right? So it's better we solve few problems based on that. So here we are going to see problems which are based on composition of vectors. Here basically, when they say composition, they are trying to talk about the resultant part. Okay. So by triangle law or parallelogram law of vector addition, the magnitude of resultant of two vectors p vector and q vector inclined to each other at an angle theta is given as r is equal to root of p square plus q square plus 2 times pq cos theta, where theta is the angle between them. And if the resultant r vector makes an angle beta with p vector, then tan beta is given as q sin theta divided by p plus q cos theta. That is, if this is p vector and if this is r vector, which makes an angle theta here, and let's say this is q vector, then tan beta will be equal to q times sin theta divided by p plus q times cos theta. So having said this, we will start the problems. ABCD is a parallelogram. ABCD is a parallelogram and AC vector and BD vector are its diagonals. A, B, C, D is a parallelogram such that not for all parallelograms. No? So AC vector and BD vector are its diagonals. Okay. Now I can take this as AB vector and this is BC vector, this is CD vector and this is AD vector. Sorry, DA vector. Right? For that, what I will do is I need to prove AC vector plus BD vector is 2 times BC vector. So how do we do this? Whenever you have sum of two vectors, what are we supposed to search for? Triangles. So search for the triangles in such a way that I have AB, BC and AC. So what can I write here? AC vector is equal to AB vector plus BC vector. Let me call this as equation number 1. In a similar way, I can say if this is DA vector, this is AB vector, and I have BD vector. If you see, all the three are in continuous path. So when they are in continuous path, what happens is DA vector plus AB vector plus BD vector will be equal to 0 because they don't follow triangle of addition here. What does triangle law tell us? If two vectors are taken in order, the third vector is supposed to be in the reverse order. So what I can do here is I can write AB vector plus BD vector is equal to negative of DA vector, or this can also be written as AD vector. So negative of dA means what? D will become the ending point and A will become the starting point. So if it is only dA vector, D is the starting point and A is the ending point. If it is negative of dA vector, then D becomes the ending point and A becomes the starting point. So it should be written like this. That is AB vector plus BD vector. Am I clear with this? Right? Now what are we supposed to find? AC vector plus BD vector is what we need to find. So if I add the first equation and second equation, I'll get AC vector plus AD vector is equal to, or I'll add the left hand sides. AC vector plus AB vector plus BD vector is equal to AB vector plus BC vector plus AD vector. Is that point clear? So what will get cancelled? AB vector and AB vector are gone. So I have AC vector plus BD vector is equal to, I have BC vector, which is to be proved. But I also need to prove that AD vector is equal to BC vector. So how do we do that? How do we do that? For that, you need to take another triangle and then prove it. First, copy it till this step. Is it clear till this step? Is there any doubt till this step? Now take the other two right angle triangles. Oh, sorry. Now take the other two triangles and try to write the expression for triangle of addition. So the hint that I would give you is, You have A, B, C, D, right? Right. So you consider the triangle BCD. So if this is BCD, BC vector, CD vector, and let this be BD vector. Okay. Then what can I say about them? BC vector plus CD vector is equal to BD vector. Accepted. Why is it so? Because of the triangle of addition. Similarly, if I take these, if I take the other triangle B or DAB, so I have DA vector, AB vector. I think we have already taken this triangle, no? Did we consider this triangle already? So what is the first expression? The first expression is AC vector is equal to AB vector plus BC vector. And the second expression is AB vector plus DB vector is equal to AB vector plus BD vector is equal to AD vector. Then we have BC vector plus CD vector is equal to BD vector. So what are we supposed to prove, guys? AC vector plus BD vector, AC vector plus BD vector is equal to 2 times BC vector. Now see what can you do with these three expressions or three equations. So if I observe the third expression, can I write BC vector is equal to BD vector minus CD vector? Can I do that? Right, observe. BD vector, I am leaving it as it is, I am not disturbing it. So if this is CD vector and this is AB vector, what is the relation between AB vector and CD vector? AB vector is equal to negative of CD vector. Why? Same magnitude, opposite direction. They are opposite vectors, right? So minus CD vector, can I replace it with AB vector? Can I do this? Let me call this as 4. Now observe first, second, third, and fourth. If you compare 2 and 4, what can you say? AB vector plus BD vector is AD vector, or this is also same as BC vector. So what is the conclusion? We got an expression already here. AC vector plus BD vector is equal to BC vector plus you have AD vector here. You have that step, no? So here what did we prove? BC vector and AD vector are the same. So when BC vector and AD vector are the same, what can I conclude? AB vector plus BD vector will be equal AC vector plus BD vector will be equal to 2 times BC vector. Is that clear? So it's unfortunate that the first problem itself is tough, but others are based on numbers. So if you see, this is a purely vector algebra based problem. Means you need to solve the problem using only triangle operation. Clear? So did you make a note of this point? So next one we can solve. What is the next one? They've asked us to write. So they proceed. So next part is AC vector minus BD vector is 2 times AB vector. AC vector minus BD vector is 2 times AB vector. How to prove this? For that, what I will do is I'll add the first equation and second equation. Observe. So when I add the first equation and second equation, I'll get AC vector plus AB vector plus BD vector is equal to AB vector plus BC vector plus AD vector. But just now we proved that okay. I'll do a reverse addition. So I'll add AC vector and AD vector will be equal to AB vector plus BC vector plus AB vector plus BD vector. Observe this. AC vector is added to AD vector. So AC vector plus AD vector is equal to AB vector plus BD vector plus AB vector plus BC vector. So here the advantage is, what I can say is BC vector and AD vector are the same. That's what we have proved. Right? Now what I can do is AC vector, this BD vector is there. Now it will come to the left hand side as minus BD vector is equal to AB vector plus AB vector will be 2 times AB vector. So that's what they asked us to prove. Okay. So this is a maximum level of application that you can have in triangular. If you're able to master this, we will have better clarity. Here. Shall I proceed? Okay. So solution is given here. No. The second problem is a body is simultaneously given two velocities. One 30 meters per second due east and other 40 meters per second due north. So one is 30 meter per second due east, and the other is given a velocity of 40 meter per second due north. Find the resultant velocity. So if you observe, this is a scenario where you have co-initial vectors. So whenever you have co-initial vectors, the first thing you do is apply parallelogram law of vectors. So the resultant will be in this format R, and R will be equal to square root of, if I call this as A, if I call this as B, it will be A square plus B square plus 2 times AB cos theta. So R is equal to root of A square is 900 plus B square is 1600 plus 2 into A into B into cos of 90 degrees. So because that is the angle between both the vectors. So cos 90 is going to make this whole expression a 0. So you will have root of 900 plus 1600, which will give you root of 2500, which is 50 meter per second. So the resultant of these two velocities is going to be 50 meter per second. Is it clear, guys? Are you able to understand? So did you understand when to apply parallelogram and when to apply triangle law? When will you apply parallelogram? When you have co-initial vectors. When you have continuous vectors, you will start thinking of triangle law, but mathematically they both mean the same. Shall I proceed? The third question is, a particle has a displacement of, if people try this, charge and maintenance is over. How many of you could solve this? You got an answer? Anybody who could get the answer? First of all. Now let's see the third problem. There is a particle which has a displacement of 12 meter towards east and 5 meter towards the north and 6 meters vertically upward. So particle has a displacement of 12 meter the east, 5 meter in the north and 6 meter vertically upwards means along the z axis. So 6 meter along z axis, because north, east, west, and south, everything is lying in the plane of the paper. Okay. So if I take this as O, E, and F, if I join these two, so if this distance is 5, is this distance is 12, then how much will this distance be? Then how much will OF be? It will be square root of 5 square plus 12 square, which is going to give you 13, because 5, 12, and 13 are Pythagorean triplets. So OF's magnitude is going to be 13 meter. Now this 13 meter is going to get combined. Now this 13 meter is going to get combined with the 6 meter, which is happening in the vertically upward direction. So let me call that point as G. And this point will be F, and this point is going to be O. So what is the value of OG now? OG will be square root of 13 square plus 6 square. That is going to be root of 169 plus 36. How much is this? Root of 215. So this is going to be square root of 205, and square root of 205 will be approximately 14.33. Because square root of 196 is how much? 14. So it will be closer to 14. So answer will be somewhere around 14.33 meter. And this is going to be the magnitude of individual displacement. But if you see the question, they ask the sum of these displacements. So the sum of displacements is going to be equal to 13 plus 14.33, which is going to be 27.33 meters. The fourth problem is there are two forces of 5 Newton and 7 Newton which act on a particle at an angle of 60 degrees between them. Find the resultant force. So this is 5 Newton and this is 7 Newton, and they both act at an angle 60 degrees with respect to each other. Then if I have to find the resultant, R will be equal to root of A square plus B square plus 2 times AB cos theta. This is going to be root of 5 square plus 7 square plus 2 into 5 into 7 into cos of 60 degrees. This will be square root of 25 plus 49 plus 70 into half. It will cancel 35. So 35 plus 25 is going to be 60. 60 plus 49 is square root of 109 Newton. Shall I proceed? The first one is there are two vectors, both equal in magnitude, have their resultants have their resultant equal in magnitude of the either. Find the angle between the two vectors. If this is a vector, the other vector is also a vector, and the resultant is also a vector because it also has the same magnitude. Okay. Or if I have to be more specific, I'll come from the beginning. See, if the first vector has magnitude A, second vector has magnitude A, then the resultant of these two vectors also has the same magnitude A. That's what they mentioned. The resultant is equal in magnitude of the either. So R is equal to root of A square plus B square plus 2AB cos theta. So if you observe the value of theta here, right, that is what we need to find. Find the angle between the vectors. So R is how much? R is A is equal to root of A square plus B is also having magnitude A. So it is A square plus 2 into A into cos theta. So squaring on both the sides, you get A square is equal to A square plus 2A square cos theta. So 1A square gets deleted. So 0 will be equal to, if I take out A square common, A square into 1 plus cos theta, or it is 1 plus 2 cos theta, which implies 1 plus 2 cos theta is equal to 0. So cos theta will be equal to minus half and theta will be equal to 120 degrees. You will be learning about this negative angles in your trigonometric function mathematics. So did you already learn? It's fine. So cos theta is half means 60 degrees, minus half is 120 degrees because it belongs to second quadrant. Okay. Why? So it will be dealt in math. Is it clear till now? So these are all decent problems. With this, I hope you should have understood what is this parallelogram law of vectors, right? So we'll do one last problem before we wind up. Okay. Shall I proceed? Sixth problem is two forces whose magnitudes are in the ratio 3:5 give a resultant of 35 Newton. So there are two forces, let's say F1 and F2, such that F1 is to F2 is equal to 3:5, and the resultant of these two forces is going to be 35 Newton. If the angle of inclination be 60 degrees, calculate the magnitude of each force. Means if I take F1 as F, then F2 will be equal to 5 by 3 times F1 because F1 by F2 is 3 by 5. So if I take F2 this side and 3 by 5 to the other side, it becomes F2 is equal to 5 by 3 times F1, or this is also equal to 5 by 3 times F, because F1 is assumed to be F. So R is equal to how much? Square root of F1 square plus F2 square plus 2 times F1 F2 cos of theta. So this will be square root of F1 square is F square plus F2 square is 25 by 9 times F square plus 2 into F1 is F into F2 is 5 by 3 times F into cos 60, which is going to give you half. So half and half will get cancelled. And don't forget, on the left hand side, you have the resultant to be 35. So squaring on both the sides, I get 35 square is equal to F square plus 25 by 9 F square plus 5 by 3 F square, which implies 35 square is equal to, the LCM is going to be 9. So here it is going to be 9 plus 25 plus 15 F square. So which is 49 F square. So 35 square is equal to 49 F square divided by 9. This problem is the sixth. This one only, no? So if you see, 35 square is equal to 49 F square divided by 9. 35 square is equal to 49 F square divided by 9, which implies F square is equal to 35 square into 9 divided by 49. So F will be equal to square root of 35 square is 35 into square root of 9 is 3 divided by square root of 49 is 7. This will cancel it 5 times. So F will be equal to 15 Newton. And F2 will be equal to 5 by 3 times F, which will give you 25 Newton. Is this clear? Okay, make a note of this. Clear, guys? So I would say this is almost, we have almost covered parallelogram law of vectors. Like it keeps going and the concept is the same. This one? Great. So there are two more important concepts left out in this chapter. One is called dot product and the second is called cross product. That is multiplication of vectors, which we'll deal it in the next class. Okay. So apart from that, any other doubt? No. So whatever are the number of problems that are remaining, I'll give it as assignment. Sit in the weekend and work. Okay, it will not take more than half an hour to 45 minutes. You can do it well. Okay, similar is the case with math also. Math also will be getting an assignment this week. Work on functions. Seriya? Yeah. Test is fine, but this week assignment is there based on functions. Okay, solve it and come. Seriya? And if you have doubts, reach out on the student support number. Make use of it. I see none of you reaching. Yeah, you have to fill the application. Is it clear? Okay. So that's it from my side for today. Shall I stop? So those who are online, shall I stop?
I have no doubts, sir.
Okay.
Thank you, sir.
Yeah. The balloon which starts rising from ground, which was at rest, it has started racing up with an upward acceleration of 2 meters per second square. Just after 1 second. Okay. So with this acceleration, what would have been the distance covered by it? S is equal to ut plus half at square. So S is equal to u is 0 plus half into acceleration is 2 into t is 1 second. So it gives you, it has covered the distance of 1 meter. Means when it was at a distance of 1 meter, they dropped a stone. Okay. The time taken by the stone to hit the ground. But the point here is, at this time, what is the velocity of the object here? So v is equal to u plus at. So u is 0. So v is equal to 2 into 1. It was 2 meter per second. So the 2 meter per second will be the velocity of the stone in the downward direction.
So how can it?
Because it has velocity. No? Generally, when you drop a stone, what you do? Only if you drop from a stationary position only, its velocity is going to be 0. But here the stone already has the velocity of the balloon itself because the balloon was inside the stone was inside the balloon. So it has a velocity of 2 meters per second. So again, applying S is equal to ut plus half at square. S is how much? 1 meter is equal to initial velocity here is okay, but it will be in the negative direction. Oh no. So displacement this direction, this time I'm taking it as positive, and acceleration is also positive. So S is 1 is equal to U is 2 into time is what you need to calculate, plus half into acceleration is 10 into t square. Because it is falling under the influence of gravity, assuming it is Earth. So 5t square plus 2t minus 1 is equal to 0. So t is equal to minus b plus or minus root of b square minus 4ac, that is 20, divided by 2. So minus 2 plus or minus root 24. Root 24 is 2 root 6 divided by 2. 2 will cancel here and here. Minus 1 minus root 6 or minus 1 plus root 6. This is ignored because it is negative. So root 6 minus 1 should be the answer. Root 6 is how much? 2 point something. So this should be the answer. I'm not sure if there is an answer. You don't know. Where did you see this problem?
Yes, sir. Yes, sir.
Yes, sir. Yeah, the problem for that. In the session.
So, but when if